Welcome back, my friends, to another CSEC exam past paper question and solution. Now, finally, we have reached section 2 on the May 2011 paper, and in this video, we're going to be looking at question 9A. Now, question 9 is that usually falls under the general topic algebra and relations, functions and graphs on the syllabus, and here in part 9 part A, we're asked to solve the pair of simultaneous equation, which is a 5 easy marks. Now, I must say to you now that this video may be a little bit longer because a few of our friends that have been watching our videos, they have expressed the concern that section 2 is generally the section that gives a lot of trouble. Okay, so what I'll be doing, I'm not going to rush through this video. I'm just going to teach the concepts, okay, and just walk you through it so that, it's easy to understand. I'm not going to skip any steps then. Okay, so quickly let's get into it. Let me just pull this up a bit so that we can have some space to work with here. Okay, now here we were given a pair of simultaneous equations, and first thing we ought to do is to label our equations. Okay, so what I'm going to do, I'm going to label my equation, the first equation, equation 1, and my second equation, I'm going to label equation 2. Okay, now basically just a quick intuition or just the concept behind this kind of question is that if you look carefully, you would have noticed that in equation 1 I had y is equal to x squared minus x, and I'm adding 3 to that, and in equation 2 I have y is equal to 6 minus 3x. Okay, now basically what is happening here is that if you remember the general concept of an equation is basically what is on the left hand side must be the same or must be equal. The equal sign means the same as what's on the right hand side. Now if you notice in equation 1 I had some expression y is equal to some expression in x. Okay, and now in equation 2, if you notice, I have y is also equal to some expression in x. Now to make the equation true, then I could say then basically since y is equal to some expression in both equations 1 and 2, I could say y, put y on my left hand side, and that is equal to y on my right hand side. However, what I'll be doing, I'll be substituting the expressions in x for y in its respective places. Okay, so quickly let's get into it. Hope that was a little bit of help to you. Now basically from here, what I can say then based on this concept that we have established is that in equation 1 we can say let's equate equations 1 and 2. Okay, now basically in equating equations 1 and 2, we're going to take equation 1, the expression in x, and I'm going to say x squared minus x plus 3, and that must be equal to I'm going to take my expression in y in the second equation, and I'm going to say that is equal to 6 minus 3x. Now what if you have noticed carefully, what I just did basically is what we have established there. This is basically saying y is equal to y. Okay, so what's on my left hand side is the same as on my right hand side. Now basically from here, if you should look at the equation that we have here carefully, you would realize that the highest power of x is 2. Now in an equation, when the highest power of the variable is 2, that is called a quadratic equation. Now remember, the general form of a quadratic equation is ax squared plus bx plus c. Okay, now since this is a general form of a quadratic, what this is saying, in a quadratic equation, the right hand side must be equal to 0. So I'm going to take everything to my left hand side. So let's do some quick transposition and take everything that's on the 6 minus 3x, I'm going to take that and put it on my left hand side. So basically what I have here is x squared minus x, okay? And if you notice, I am adding 3 to that. So let me put back that. Now here I have a positive 6, okay? Now when this positive 6 comes over, it's basically what I'll be doing. Since it's positive 6, I must do the opposite of that, which is to subtract 6 from both sides. So what I do to one side, I must do to the next side of my equation. So I'm going to subtract 6 from both sides, okay? So I'm taking over the 6, so I am left with 6, this 6 here, which is this, and then I have to subtract 6, because since I subtract 6 from that side, what I do to one side of an equation, I must do to the other side, okay? And then I have a minus 3x there, okay? Now let's collect terms. Here I have left x squared minus x, and we know that 3 minus 6 will leave us with a negative 3. You could always try that on your calculator. And we know a positive 6 will always cancel out with a negative 6. So what I have left here on my right hand side, I have a negative 3x. So basically, let's take this over. Let's take over this negative 3x. If I have a negative 3x on this side, to cancel it out, I must add 3x to both sides, which is the opposite of subtraction. So here now I'm going to say x squared. Let me just pull this over a bit. Okay, let me just pull that over a bit. So here now I'm going to say x squared minus x minus 3, and since I have a negative 3x, I must add 3x to both sides, okay, and that must be equal to minus 3x plus 3x, okay? What I did to this side, I must do to that side. So I know a positive and a negative 3x will cancel out. So basically what I have left here now, my leftover is x squared minus x, okay? And if you notice, I have a positive 3x there, so I'm going to add that 3x to that. Then I have a negative 3 there, and that must be equal to 0. Okay, so basically what I just did here, I'm just going to collect it. I've just collected my like terms right here. These are my like terms I've just collected. So what I'm going to say now, I'm going to say just calculate that to say x squared, and I know that a negative x plus a positive 3x will leave me with a positive 2x, and I'm subtracting 3 from that, and that must be equal to 0. So there now, my friends, I have my quadratic equation in its general form, okay? And what do I mean by that is that this now looks like this over here that I have, okay? Over there on my right hand side. Now quickly, let's continue. Let me just split the screen a bit, and let's move this a bit over some more. Now what we have left is a quadratic equation. So let's just quickly solve our quadratic equation. Up here I'm just going to take this up top. I'm going to take my x squared plus 2x minus 3, and that must be equal to 0. Now as I've said before, remember the general form of a quadratic is ax squared plus bx plus c. Now I'll be solving this quadratic by factorization, and by that what we mean, we're going to take the value of a here, okay, and multiply it by the value of c. So basically, to factorize a quadratic, we use the AC method. And if you notice here, in my original equation here, I have a 1. The coefficient of x squared is 1 because a is the coefficient of x squared there. So I'm going to take my 1 and I'm going to multiply that by c. And if you notice, and this is where a lot of persons make some errors, remember now the c here is negative 3. It's not just 3, but you're multiplying by negative 3. Now 1 times negative 3 will give me a negative 3. Now after I've multiplied a times c, then I need to find factors of factors. When I multiply them, I get negative 3, but when I add them, I will get a positive 2 right there, my b. Okay, if you make some comparisons, I should get my B. Now, factors of 3 are 3 times 1. Okay, and if you notice, if B is positive 2, then I'm going to have to change the sign on one of these factors. So I'm going to say negative 1. So I have changed the sign on my 1 to make it a negative. So 3 times negative 1 will give me a negative 3, which is my C out there, or which is the product here rather. This product that I'm circling, negative 3, and if you should add 3 plus negative 1, you'll get a positive 2. So these are the factors that I'll be using. So therefore, my factors are 3, positive 3, and negative 1. Okay, now let's use them. So I'm going to expand this middle term now to say x squared, okay, plus, and I'm using the 3x now, so I'm going to say 3x, and then I'm going to use the coefficient, my negative 1 as a coefficient, so I'm going to say minus x minus the 3 that I have out here now, and that must be equal to 0. If you notice what is happening, the middle term 2x, the value of that hasn't changed, it's still the same, because 3x minus x will still give us a 2x. Okay, so now quickly I'm just going to factorize this by saying take out what is common. So I'm going to say x into x squared, since x is common to x squared and 3x, so I'm going to take out that x into x squared will leave me with an x, and x into 3x will leave me with a positive 3. Okay, so that's a plus 3. So now I'm comparing again my sign here. I'm going to take down my negative sign, and if you're not sure about a factorizing a quadratic, you could always check out our playlist, okay, on solving quadratic equations, where you look at various ways of solving them. Okay, now let's get into this. Let's finish this up. If you notice, I bring down my sign, so I have a 1 that is common to x and 3. Okay, so I'm going to place it there. So negative 1 into a negative x will leave me with a positive x, and negative 1 into negative 3 will leave me with a positive 3, close bracket, and that is equal to 0. Now what is happening here now, guys? If you notice, the same thing is inside the brackets. Okay, so what I have in my bracket here, I have it there. That's the critical thing. If the same thing is not inside the brackets here, then something is wrong. Okay, so basically what I'm going to do here, I'm going to write down what's inside one of my bracket, because if you notice, that is what is common to these two terms. Okay, in x times x plus 3 and negative 1 times x plus 3. So if you should factor this out, you would get an x here, because you could say x plus 3 into this would leave us with this x there. So I brought that down, and I'm saying x plus 3 again inside this over here. So basically I would be left with a negative 1. Okay, so some persons may teach it as you would write down what's inside one of the brackets and combine what is on the outside, okay, of the other two. And if you notice, that's what we have there, and that must be equal to 0. Okay, now basically I have my two factors, so what I'm going to do next, I'm going to equate them to 0. So I'm going to say x plus 3 must be equal to 0. Okay, or x minus 1 must be equal to 0. Okay, so really what I have left here, I have a 3 adding to x. So to get rid of that 3, I must do the opposite of addition, which is subtraction. So I must say x plus 3 minus 3 is equal to 0 minus 3. What you do to one side, you must do to the other side. So a negative 3 will cancel out with a positive 3. So we're left with x must be equal to 0 minus 3. We know that is a negative 3. Or over here, I can say then now that if since 1 is being subtracted from x, then I must do the opposite, which is x minus 1. So since that's negative 1, I must do the opposite, which is to add 1 to take it over, and I will have a 0 plus 1. Okay, now here I know that a positive 1 will cancel out with a negative 1, so I'm left with x is equal to 1. Okay, so now basically what we have had here, we have gotten our two values in x. Okay, but if you notice the original problem that we have here up in my top left hand corner, we had equations in y's. So if I've gotten two values for my x. Now I must find my corresponding y values. Okay, so in completing this now, I'm just going to move this so that we have a little bit more space to work with. So just hold up for me a bit. Now, since I have my two x values, as I've said, what I'm going to do now, I'm just going to basically take each x value and substitute it in the simplest equation, which is equation 2 here, to get my corresponding y values. So here now I'm going to say substitute x is equal to, let's say, positive 1. Let's use that, the positive 1 value first, into equation 2. Okay, so equation 2 states that y is equal to 6 minus 3x. Okay, so in substitution I must say y must be equal to 6 minus 3 times 1. Okay, because x is 1, I've removed the x, placed the 1, so y is equal to 6, and a negative 3 times a positive 1 will give us a negative 3. So therefore y is equal to 6 minus 3, which is equal to 3. Okay, so when x is 1, y is 3. Now in my second value for x, I must say substitute x is equal to negative 3 now. Okay, into equation, and I'm going to put it in equation 2 again. Okay, so equation 2 states that y is equal to 6 minus 3x. Okay, that's equation 2. So I'm really saying y is equal to 6 minus 3 open bracket, and now x is negative 3, so I'm going to place my negative 3 there. So here I have y is equal to 6, and a negative 3 times a negative 3 will give me a positive 9. Okay, 3 3 is 9, negative times a negative will give me a positive. So therefore y is equal to 6 plus 9, and that will give me a 15. And that's it, my friends. So we have calculated the two x values and the two y values. So therefore we just make our statements now. Since we have a little bit of space over here, therefore we can say when x is equal to negative 3, y is equal to, when x is negative 3 down here, y was equal to 15. And then we can say when x is equal to, let's put it here, when x is equal to positive 1, y is equal to positive 3. And that's it. Hope this was helpful. Hope you can understand it a little bit better now. Anyway, if you have your questions still or comments, feel free to post them and we'll get back to you as soon as possible. Okay, bye bye.